In this video, surface area of pyramid 7.7, we are looking at the surface area of a, go figure, pyramid. It's got a base. It's got triangular sides that lead up to a point. The difference between pyramids and prisms is that the pyramids have only one base and triangular faces, and prisms have two bases and rectangular faces. So the one we're working on today, pyramids. You'll be finding the surface area of square pyramids. Square pyramids are made up of a square and four triangles. Since the base is a square, all four triangles are congruent. So in both cases here, we have a square base. This base happens to be 16 by 16, and this square base happens to be 17.5 by 17.5. Sometimes a square base will also have like tick marks, and they might only label one of the four sides instead of labeling two to prove that it's a square 16 by 16. Sometimes they only label one and then use the tick marks. It's a square with four congruent triangles. To find the surface area, add the area of the base to 4 times the area of the triangles. Now, the two that are on the front, do you notice that there is a line on the triangle that is labeled? That is called your slant height. So slant height, which is exactly what it sounds like, it's the height on the slanted side. It is represented by a lowercase cursive L. So I can only assume S was taken, so they went with the next letter. So slant height is if you were to sit on top of the pyramid and slide your bottom side along the face, the track that your bottom would take as it went down the slanted side of the pyramid, that would be your slant height. So let's start with area of the base. Area of the base is a square, so side squared. So in this case, we're going to do 16 squared. Area of the base is 256 inches squared. No big deal. Then we need the area of the triangles. So the triangular faces. The triangular faces, let's see. Area is triangle, so 1/2 BH. So 1/2, the base of the triangle along the bottom here is 16, and lowercase h, which is the height, which is your slant height, that is 18 on this one. So your area of it, the single triangle, 1/2 times 16 times 18. If I do 16 times 18, I get 288, and half of that would be 144 inches squared. Now, you'll notice it said in the directions, add the area of the base to 4 times the area of the triangles. Why is that? I have one base, 256, plus 4 triangles. Each of them is 144. 256 plus 576. So the surface area of the whole pyramid, 832 inches squared. And we're done. One base plus 4 triangles. So I had to find the area of the base. That's a square, no big deal. Had to find the area of the triangle. Not terrible, as long as we're picking the right numbers. And I need 4 of them. All right, so let's see if we can duplicate that. Down at the bottom, I have a new regular pyramid, or a pyramid with a square base. First, I need to start by finding the area of the base. So the area of the base is S squared, or 17.5 squared, right? So into the calculator, I would have to type 17.5 times 17.5, 306.25 inches squared. The triangle. A triangle is 1/2 BH. So this slanted side, we said that is slant height, also known as lowercase h because it's the height of that single triangle. This side down here, the 17.5, that's the base of the triangle. And then the height of the triangle, or slant height of the pyramid, is 20. Now, it's easiest to take half of 20. So we do 10 times 17.5. The area of a single triangle, 175. Because it is surface area of a pyramid, I have one base plus 4 of the triangles. One base, and when I do 4 of the triangles, I get 700. And when I add that all together, 1,006.25 centimeters squared. Not terrible. Again, base, it's a square, so side squared, area of a triangle, and I need 4 of the triangles. Now, when you flip over, you're going to look at this and think, oh, I don't really see all that much different, right? Big deal, pyramid, you just did this. Well, you'll notice this time that I'm labeling this thing that is inside the pyramid. If you're Indiana Jones and you climb up to the top, right, and you're right here at that vertex, and you drop a rope down the center of the pyramid so that you can stand on the floor of the pyramid, that rope is the height of the pyramid, or capital H. It is not the same as slant height. You'll notice over here what we've done is we've drawn that 12 that goes straight down the middle as this little side triangle. So right here, here's the 12 that goes down the middle. That's Indiana Jones rope. The thing that we are looking for over here is slant height. That's the thing we don't have. The base is 10, right? It's a 10 by 10 square. So when we pull this little triangle out, you'll notice that we only end up using 5 because it goes from the rope out to the edge. It's only half of the distance. It's right here from the rope out to the edge. So only 5 meters. Before I can do anything, I need that slant height. I cannot use any of my formulas without the slant height. So this is the thing I'm looking for, slant height. In order to do that, it is a right triangle. Hopefully you all agree. You can see that there's a right angle there. So we are going to start by using the Pythagorean theorem. We're going to start with a squared plus b squared equals c squared. I'm looking for this slanted side, which is the hypotenuse. So I've got my 5 and my 12. Those are my legs. 5 squared plus 12 squared equals the slant height squared. That again, we don't know. 25 plus 144 equals the slant height squared. That's going to be 169 equals the slant squared, and we're going to have to square root both sides. 169, I said 169. 13 is our slant height. So that number that we needed here is 13 meters. Once I have that, I'm good to go with everything that I did on the front. That extra step is required when you have the height of the pyramid, Indiana Jones rope, instead of the slant height where you slide on your bottom down the slanted side of the pyramid. So now I'm ready to go. I'm going to start with the area of the base. It's a square. So it's going to be 10 squared or 100 meters squared. I also need a single triangle. The single triangle is going to be 1/2 BH. Just found that H that I need, right? The slant height. So area equals 1/2. The base is 10. The slant height we found was 13. So 5 times 13 or 65 meters squared. Have all of the information that I am going to need because I need one base plus 4 triangles. One base of 100 and the 4 triangles are worth 260. So the surface area is 360 meters squared. One base plus 4 triangles. All right, so let's see if we can apply that to the missing slant height on the last question, number 4. So we have a square base that is 12 by 12. We have Indiana Jones rope hanging down the center at 8. We also know that from his rope over to the edge is only going to be 6. It's not all 12. And the thing we're looking for is the slant height. So the missing slant height. All right, so we're going to use our Pythagorean theorem since that is missing. A squared plus b squared equals c squared. A is 6. That's one side of the right triangle. B would be 8. That's the other side of the right triangle, the rope, equals the slant height squared. So 36 plus 64 is going to be 36 and 64, 100. And I have to square root both sides. So 10 is our slant height. I'm like, oh, great. That's an easy number to work with. Yay, whole numbers. So slant height is 10 feet. All right. Area of the base. Again, we're only working with square bases for right now. So the area of the base is going to be 12 squared or 144. The area of a single triangle, 1/2 times BH. Remember, slant height is also our H. So 1/2 times 12 times 10. That's a half times 120 or 60 feet squared. And because it's surface area of a pyramid, I need a single base. and 4 triangles. The single base of 144 plus 240. Overall surface area, 384 feet squared. Not terrible. However, we like it a lot when the slant height is provided. We do have to do one extra step, the Pythagorean theorem, when slant height is not provided.